In this lesson, I'm wanting students to sketch pictures of the given information to apply Pythagorean theorem, and I also want to introduce them to the 45-45 90-degree triangle so that they can easily find exact answers based off of that formula and then change it to approximate answers if needed in this lesson. And so the first one had the DVD player was 8 by 8. Well, if they went through the Pythagorean theorem, they could have found that 8 squared plus 8 squared equals c squared, and when squaring both of those, 64 plus 64 was 128. Square both those and add those would be 128 equals c squared, and you take the square root. Well, I said to find the exact length in this one, so they have to leave it in radical form. Well, it looks like 4 goes into that. 4 goes into 12 3 times and into 8 2 times, so 4 times 32 must be two factors that make 128. And you continue breaking it down. You can go to prime factorization or look for a 16 times 2 would be a perfect square. We can use the perfect square method. The square root of 16 is 4. That's going to come out. And then the square root of 2 times 2, you're going to get a 2 come out for the pair. And then a 2 is left underneath. So it's 8 square root of 2. And then if we look at the next one, it was a square, a DVD player that was a little bit bigger. It was a 12 by 12. And again, it was a square. So the sides were all equal, form a 90-degree set each corner. Looking for that diagonal. Again, if you go through that, you're going to get 12 squared plus 12 squared equals c squared, and 144 plus 144 would be 288 equals c squared. Well, when you break down square root of 288, here because I'm out of room. Let's see what goes into that. 4 would go into that 7 times into 28 and 2 times. And then, let's see, 72 would be 6 times 12. You can start with any two factors, 2 times 6, 2 times 3, 2 times 3. And I'm looking for pairs. I can pull out a 2 for the square root of 4. You can break it down to 2 times 2 if you don't see that. So a 2 is going to come outside the radical, and then I have another pair of 2's, which is a 2 comes out for that pair, another pair of 3's, a 3 comes out for that pair, and then a 2 is left underneath because it doesn't have a pair, it can't come out. And so remember, once the numbers were broken down, they no longer count because they're represented by 2 other numbers. So you end up with 2 times 2 is 4 times 3 is 12 square root of 2. Well, and then in number 4, I bring up what is the pattern of that? What are you noticing about the pattern when we look at the squares? It's different when they do the rectangle one and number 3, and they'll see that. But then you come down to number 4 and you talk about the pattern of the squares. Well, they both ended up with the leg times square root of 2. And I talk about, well, that's the formula. You have both the legs are going to be equal because they're isosceles right triangles, and it forms 45, 45, 90 degrees, and I draw that out for them. And then we talk about if you take that leg times the hypotenuse, it's the leg square root of 2. So you're always multiplying that leg times the square root of 2.